That I'd like to introduce the Google team. They are from the cloud team, and they will be taking you through an end-to-end experience with machine learning. All right, go for it, guys. Please give them a round of applause.
So me and Manoranjan, we both come from the Bangalore office of Google. I work in the cloud team. He works at a team called as Developer Relations. Both of us work with the agenda that we want to help developers of all shapes and sizes figure out how to use Google Cloud, how to use some of our open source products like Tensorflow that we're going to be talking today, right? Uh, yep. So before we start with machine learning, right? Machine learning is too advanced a topic. It has today become a buzz that if you do not write machine learning on your resume, or if you don't say your startup is AI enabled, you're probably doing the wrong thing, right? You're not in the race. But like effectively, how do you guys use machine learning today, right? Effectively, how does machine learning help you guys? Do you have any use cases of that? Does anybody want to share how machine learning helps them? Sure. So if you guys know, there's a product called as Google Photos, which is there for cataloging and sharing your personal photographs. Using that, what you can do is you can have them arranged automatically, create collages and stuff like that. Right? That's great. Okay, superb. Any more use cases? We're still not earning money with photos. Google? Okay. Android, great portion. A lot of things that you see in Android happening, something like what my friend here mentioned with screens, and then there's a lot more stuff, be it cataloging your apps, telling you what app to install next and stuff like that, helps you. Uh, let's stop talking about Google, right? I hear about Google all day long. I'd like to hear things outside of Google, like maybe other companies, maybe your personal lives, maybe some projects that you guys are working on. Alexa, yep. How does Alexa help you? It helps you do tasks. Okay, cool. It helps you do tasks. It makes a to-do list for you. Driverless cars. Yes, I wish they were helping me today. They are not in India, but yeah, if you're out there in some of the regions where driverless cars are allowed and you can own one of them, it's a great help, right? Uh, I don't know how often do you guys like? How many of you are here from the same campus? Okay, super. Most of you are, so you don't really know what the traffic outside the world looks like, but it's really, really painful, right? Facebook newsfeed, okay, yep. They try and show you things that are relevant to you, that are probably something that you are interested in, you shared recently, right? All of this is great, right? We're still talking about things that are fun, right? Except driverless cars, most of the things are fun. Let's talk about things where they help you make more money. Recommendation systems in e-commerce, yeah, definitely, right? Something that one of the IBM speakers also talked about is figuring out what you like, giving you more of that so that you can buy that. Basically, propagate a buyer persona inside you so that even what you didn't want to buy or didn't know that existed on that store, you can start buying, right? You guys know about stock exchanges, right? BSE, NSE, NYSE, stuff like that, right? There's so much trading that is happening nowadays. Do you guys know recently NSE hit a bump, right? Did you see the trading volumes on that day? They crossed 100 CR, right? Within 4 hours, 100 CR of trades. That was more than 60% of what they were regularly expecting, right? That is what caused the breaker to shift off, right? Do you think there were 100 CR people, or at least maybe a subset of them, that were triggering these 100 crore trades to happen? How many of you think that's what is that? No, it's a lot of automatic trading that is happening. Who's taking the decision on these automatic tradings? A lot of machine learning, right? This is where things are now starting to get more and more different, right? So we're going to talking about, while we talk about machine learning, let's look at some of the basics of it, right? To start with, who can explain what machine learning is? Again, there are no wrong answers. I know this is called as a lecture hall, but unfortunately I'm not, well, fortunately I'm not a teacher, right? You guys are not students. We're just a group of people trying to figure out what machine learning is, maybe build something with it, try and use it, or actually be able to prove that it's just a fad and we don't really need it, right? And go back to doing what we really do, right? I hope my second statement is not true. Yeah, anybody wants to tell me what machine learning is? I heard something. Learning by examples. Okay, superb. Excellent. I think both of these, if I combine, is the answer that I was looking for, and that what I at least understand is you can definitely, you're allowed to have your own definitions, but this is what I and probably Manoranjan also correlate with, is that you can build models, right? So today, like you guys probably write some kind of languages, right? You write either PHP, Java, Go, Haskell, or C++, or whatever various languages. When you're writing those if else or for loops, right, what you're doing is you're telling the system that, hey, you know, everything that you're getting, if it matches this is what you're supposed to do, or this is the action you're supposed to take, right? But what happens if the system sees something that it does not recognize? It says, hey, I don't know, it probably issues an error, or if you have a throw or some kind of thing, you just throw it away, right? You probably log it and say that this is something that we don't understand. On the other hand, you have machine learning. Machine learning says, hey, I haven't seen this thing ever in my lifetime, but I still try to guess from what my past experiences are, which is as close as it gets to human beings, right? You all read textbooks. Those textbooks have content that you have never seen in your life, right? And you don't say, hey, I'm going to throw this in garbage. What do? You try to read that, assimilate that, make some sense out of it from what probably past experiences that you've had, right? Probably, let's talk about integration or differentiation, right? Or well, all of mathematics. All of mathematics just evolves from doing sum on various numbers, right? Even if you need to do a subtraction, you're actually doing a addition with a negative number, right? So your brain starts to assimilate and thus grows on, right? So yeah, how many of you know about TensorFlow? Right? Rest of you don't know about TensorFlow, which is great, superb, makes my session more exciting, right? So TensorFlow is an open source programming framework that Google open sourced about 3 years ago, right now, or more than that. 3 years, right? Yeah, about 3 years ago. It is right now the most popular programming framework on GitHub. It has got the most number of stars. I think last time I checked, it was about 15,000 or something like that, right? It's forked the most, right? A lot of people are adapting that and consuming it into various forms. Why is that? Because so Google's been doing a lot of machine learning effort. We've got brilliant people like Jeff Dean, Sanjay Ghemawat, and many others who lead this effort, who have been working on machine learning since the last 10 or 12 years for practical purposes at Google. And they've been using a lot of these things, and they created a subsegment of Google called as Google Brain, right? You may have heard about this organization that we have internally. Now they're into solving great machine learning problems, right? When you're talking about some of the examples that we talked about on Google, right? How Google or some of Google's products are using machine learning and making things easier for you, right? They are the people who are spearheading these thought processes, right? They are building the frameworks, they are building the infrastructure, they're building the backend for this. And the framework that they have been using to build and actually write code in is TensorFlow, right? They went ahead and open sourced this so that everybody can learn from it, as well as Google can learn back from this. What this allows us to do is listen to feedback from all brilliant developers like you, right? Look at some of the various use cases that you guys use, which is different than how we use it, and assimilate it back into something that the whole world can use as an open source project, as well as Google can benefit from, right? We can be better at doing machine learning. But before we jump onto the great bandwagon of TensorFlow, I'm going to take about 30 minutes talking about what machine learning is, discuss an example with you guys, which gives you probably more relevance into how we think or how TensorFlow is going to help you think in terms of machine learning, right? And then I'm going to hand it over to Manoranjan, who's going to be talking about machine learning specifics on, TensorFlow specifics on how TensorFlow works, what is the API framework, what is the underlying infrastructure that we have. Hopefully we will wrap this up in 1 hour of us both talking, right, which should be a relief for you guys. And post that, you will have about 1.5 to 2 hours, or well, till Mr. Kant arrives, to be able to work on this lab with us, where the objective is, given the data set of birth of babies in the US over a certain decade, right, how do you predict the weight that a baby is going to be born based on certain features? Right. So it's a real data set that we've assimilated. We've created the lab for you. You should have access to it. I think some codes were given out And if you were one of those folks who were able to register online directly, you can still do it, right? And these labs are going to be available. The code is also open source. So we're going to still leave you with all of that as we end the session today. Great. So what you see is an apple and an orange, right? All of us see an apple and an orange. Anybody would like to debate this is a melon or a pear? Or well, this is not a fruit at all. This is actually a, I don't know, a penguin, right? Okay, so we all have that similar understanding. How did we gain that understanding? Right. Let's think about it. When was the first time you realized this is an apple? Anybody want remembers when was the first time you guys realized this is an apple? I know it's a very stupid question, but it's actually the basic of how we start thinking about machine learning, right? Somebody told you, right? What did somebody tell you? They probably showed you one apple, right? It could have been green or red in color, or maybe a mix of that, right? And they showed you, hey, this is an apple. Like probably like my dad or my mom would have told me, hey, bacha, ye ek seb hai, right? This is an apple, right? So you start with that, and then, but they showed you one apple. But later in life, today, we show you any apple, which is definitely not similar to the apple you saw the first time. How do you know it's an apple? You start building some features around it, right? You start saying that, hey, I've got an apple, I've got an orange. The apple has a reddish color. For this example, let's take, I'm talking about a red apple, right? The orange has a orangish color, but there are apples that are orange in color also. And then there are oranges that are red in color also, right? So color wasn't enough for us to figure out. We added another feature. We said, hey, how does this taste, right? Usually apples taste sweet, right? And usually oranges taste somewhat sorry, right? We'd agree with that, right? And thus you start building some labels over it. Now you could have been called anything, like I was taught in Hindi, so I call it a save, right? Maybe in German or maybe in French or maybe in whatever your native language is, which could be Punjabi, Bengali or whatever, it could be called something else, right? What do we call this in like any other language? Does anybody know? What's an apple in some other language? Sorry guys. Pardon? Pom, French, right? Great. So elite friend of ours knows French, amazing stuff. It's called a pom, right? So they call it a pom, right? It's just a label. But somebody could argue and come up and say, well, already some people have trademark on one of the brands, right? So you could come up and say that, hey, this is my, and you cannot use this for this fruit, so now give it some other name, right? And maybe we all start calling it pom, right? Or maybe we start calling it Rohit, right? I don't know, something may happen, right? In that kind of a scenario, you just need to change the label, but the attributes, the feature that you're recognizing, it still stays the same, right? And we're going to try and build or teach our machines, right? Teach our laptops the same thing, right? Yep. So machine learning, as well defined by two of my friends here, is that it is the ability of a program or ability of a system to automatically learn or take a decision or answer without being explicitly programmed, right? Basically, without showing all the possible apples in the world, I need my system to be able to look at it and tell whether it is an apple or not, right? So coming to some of the core concepts, right? This is one of the biggest debate that probably we all can also have, but I've had with a bunch of folks, including Manoranjan here, right? We've spent hours and hours over it. Like, where do you cut the line between artificial intelligence and machine learning, right? If this slide is something that you do not agree with, I would love to discuss this with you and get your views on it, right? That, hey, no, AI is this and ML is this. There are theories, and actually I trust with one of these theories which says that artificial intelligence actually started the first time back in 1950s, right? And some people even argue that much before that artificial intelligence was there, right? We can keep arguing about it, but not during this session. We're limited on time, but definitely after this. But to just give you an overview, right? What we're calling is artificial intelligence is the summation of all programmable intelligence that we can have, right? Among it, a very small subsection, though shown largely here, a very small subsection of that is called as machine learning, right? Which could be building models like SVMs, right? Vector models using neural networks, using regression-based or decision trees, things like these, right? Using these kind of technologies or formations to be able to do machine learning. And further on, we have a further small subsegment in machine learning called as deep learning, right? With the advent or at least the popularization of deep learning, is that today we are having machine learning sessions probably every weekend in this or every other city in India, right? Before deep learning, machine learning as a name or machine learning as a technology was pretty uncool. It wasn't that it wasn't there. People were doing it. People at top institutes, people at top companies, people who have dedicated their lives to this, writing books and writing tests about it, were still doing machine learning, right? It was just wasn't cool, right? I wouldn't have been there. Actually, both of us were not talking about machine learning, though we knew what machine learning is and we were implementing that in our daily jobs. We were just not talking about it, right? With deep learning is when suddenly things started getting hot in the market, right? Yep. So just so that all of us are on the same terminology or throughout the session that we're going to do, we have a model, right? So think of model as a black box, right? Or as a brown box, right? The box that you package, right? Now this box has an input and an output, right? What does this model do? I give it an input for my, coming back to my Apple example, I give it an image of an apple and it tells me an output yes or no whether this is an apple or not. Sometimes my box is better, it's more advanced. It can give it whether it is an apple or not with some kind of certainty, right? So it can give me a percentage or a probability. And you'll see a lot of machine learning systems, especially the ones that are pre-baked. If you're using some of the machine learning APIs that a lot of the providers, including Google, offer in the world, what you'll see is you give it an image, you give it a soundbite, you give it a text, and it will give you a label with a certain certainty that, let's say 0.90 is the probability, or it's the 90% probability that hey, this image is an apple, right? So you have a model, right? The model is that box which you will build, which you will train, right? And we'll keep talking about what that does. Further, we have label, right? So you remember that chart? Label is what we're going to call a certain thing. So if I were to be conspicuous and if I were to teach my model, right, that hey, whenever you see a picture of Rohit, the output should be super cool guy. And I don't tell it, hey, this is not Rohit, say super cool guy, right? Now I'm giving it a label that hey, whenever you see this picture, which is of me, please always output super cool guy. Whenever you see a picture of Manoranjan, always output or try and out nerd, right? So these are, it's just labeling, right? I can give it any kind of labels. Features is what it will try and recognize from us, right? Probably our heights, our intelligence, or various things that I'm able to give my model as input. Finally, example, right? So example, or commonly known as learning data, right? It is a set of inputs and outputs. So I know initially we talked about that, hey, you are not explicitly programming the system that what to do, and that is machine learning. But that does not mean that a system that has not seen anything in this world or has never seen any kind of data that you're going to send it is going to be able to tell what it is, right? Like how we were taught, we had to be taught during our early lives, right? The model also has to be taught with some training data, with some example data to say, hey, these 10 images are the super cool guy. These 20 images are the nerd guy, right? Now you differentiate who it is. So yeah, there are, well, I think there are more that are coming up, but generally there are 4 categories of models that you can build, right? There are supervised models that you can build. Now, a supervised model is where you're telling it each and everything very specifically, right? A supervised model, you're looking at it like you're supervising it, right? You're looking at how the training is going on. You're looking at every subsection of new cut that it does. Whereas unsupervised model is where you do some training for it or give it some initial data to work with. Once you've trained the model, then you say, hey, now you're on an auto learn scenario, right? So it's basically, you know, that movie scene that you get to see where like the parents are finally leaving the hand of the kid and saying, hey, now you're on your own in the world, right? So initial years, the parents were supervising the kid and saying, I'm going to look at everything that this kid does, right? And I'm going to try and mold the kid in a very great, like positive shape. And then you have disasters like me that happened. My parents tried hard, but I couldn't turn out well. And then they finally were like, hey, now we don't care. Now you're on your own, right? Now you build your own experiences while you go out in the world. Uh, there is also a mix of semi-supervised, which is probably what Indian parents are, right? They never stop looking after you, they never stop caring for you. So yeah, that's semi-supervised. You train them initially, but then you keep an eye on what the model is doing and how it is growing or how it is learning, right? How the model is taking shape. Finally, reinforced learning, right? So this is again the most popular thing that everybody wants to build. I think spending about uh, 3.5 years in machine learning, have till date not built a single model that is reinforced learning. So yeah, while it sounds pretty cool, I don't know how much achievable it is. But yeah, reinforced learning basically means is, hey, take some data, process it, and you may fail, right? You may give the wrong output, but then look at that output and try and learn from it, right? Build the self-learning system within it, right? Now this cannot be the answer for every this thing. Why? Because you can't have experiences on everything, right? Like for example, uh, can you have a live reinforced learning model for self-driving cars? Yes, I'm going to keep throwing these things where if you laugh, I know that you're listening to me. If you don't laugh, I kind of understand that, hey, now you're sleeping, you're already disconnected from me, right? But the basic idea is that for certain things you can take a risk, like let's say AlphaGo, right? A machine learning model, a machine learning system that Google built to basically play the Go game, right? If you know what Go is, basically a mix of checkers and chess with I think 2 to the raise for 256 more possibilities of moves than chess, right? So it's a super complex game. It's very popular in, or well, moderately popular within nerds in China and Taiwan and the similar region, right? And the system, this AlphaGo system, which was our machine learned system on Go, went ahead, played these games, and it was able to learn from it. Why? Because the loss was nothing, right? It lost, it said, hey, what moves could I have done differently which could have helped me win, right? And it kept training, it kept training, it kept training, and finally it was able to win the World Masters Championship on Go, right? So yeah, that's reinforced learning. Into supervised learning, right? So imagine you have a snack vendor, right? If you've seen one of these or used one of these in your life, you know what this is. It's a snack vendor. Basically, there are a bunch of snacks here and there. There are numbers you can press. You're supposed to push in currency, right? You give it currency. So let's say my snack vendor here only accepts coins, and it can accept a bunch of these coins, right? But I don't want to explicitly program that, hey, what coin is what, right? Generally today when you use them, they all have currency explicitly programmed. So they see a currency note or a currency coin, and they explicitly know what this is. If they can't recognize, they do the lovely thing, and if you use one of this, which is the most irritating thing, they push back the currency at you. And I'm like, what the hell? Right? I want a snack, I'm hungry. I want a drink, I'm thirsty. And what you do is throw back my currency at me. Like, are you saying my money is not good? Right? So I consider that as a insult. So I wanted to build this which does not insult you, right? Which takes your currency, recognizes what it is, right? Even if it is slightly crippled, or let's say suddenly some country went through some demonetization, right? And now we've got all new different kind of notes, right? And we still need to recognize, or we have different kind of coins. We still need to recognize what it is, right? So it's not like it will just be able to see a new paper and you can write 20 on it and it will say, hey, this is 20 rupees, serve the fellow a Coke or whatever, right? So, yep, I want to do this, right? So what I'll do is I'll initially put certain coins and tell that, hey, this coin, this is worth $5 or 5 cents or whatever I want to specify, right? I can say 10 rupees, 100 rupees, and whatever I want, right? And for coins, a great way to recognize them is weight, right? And if you know the whole concept of coin, if you've read the history of currency, started with weights, right? What they started was that, hey, how do you, so basically barter was getting difficult. I could not trade sheeps anymore with Mano to, hey, take these 300 sheeps and build a machine learning model for me. He said, no, give me hard currency. Like, what will I first of all do with 300 sheeps? And the second thing is, like, carrying 300 sheeps is a problem, right? Imagine 300 sheeps walking behind Mano right now on the stage, right? There will be no place for me to stand, right? So what we have is we can use weights, right? So currency started, like, they started building these symbolic, well, pieces of gold that were of some value. Then they moved to some cheaper metals, right? And they started putting some value. So we go with the same methodology. I say the weight of a coin helps me determine what the value of the coin is, which is superb till you think about if the coins have been in rotation for, let's say, 100 years or 20 years, right? It's metal, it will fade off, it will drag off, the coin probably hit the floor, some metal bumped off, right? The weight keeps reducing. So I'm able to generalize them with my machine learning model. I'm telling that, hey, look at the range of a model, right? Could we have the next slide? Yeah, look at the range of the model and put some cuts there. And thus you're able to bring up some value, right? So tomorrow if you see a coin in a certain range and a certain size, it'll probably be able to predict, most hopefully correctly, so that my business is not going in loss, but hopefully correctly, that hey, I've got a coin of this value, right? Moving on. Yep. Oh, coming to the unsupervised part, right? So while I am the less intelligent, less talented person on the stage, Mano's super more intelligent. He was like, you know what, Rohit, I don't have time to train a machine on what coins look like and what coins weight like, right? I'm just going to tell it, look at bunch of these, right, and start figuring out what to do, right? So what it does, well, his system did was his system was able to even look at newer and newer currencies that were coming, diversify them by weight, right, and put a value, right, assuming that still we are doing the coin is valued by some weight and size that it comes through, right? So thus, what he was able to do, he was able to create a second diversification, or well, the last diversification, the n plus 1th diversification that you see, right, in a certain data set to say that, hey, this is a separate entity, or this requires a separate label of its own. Yep. Semi-supervised? Yeah. Go ahead. Anybody wants to laugh? It says terrorism network there. Yeah. So the example here tries to say is that assume you have a bunch of terrorists that you're trying to identify in the whole system, right? And you're looking at some transactions or some things that they do in the whole network, right? So what we're trying to identify, where are they using their cards? Where are they using mobile phones? What calls are they making, right? What SMSs they are sending? When are they buying new SIMs, right? And the blue ones, as you see, are the ones active today, right? And the gray ones is something that they left behind, right? So what we're trying to build here is we are giving it initial data that, hey, the gray one is what we know from previously. This is how this terrorist group was operating at a certain amount of time. And then we say, now you look at newer data and try and find similar patterns, right? If you find similar patterns, build new features, use those features to identify, hey, that is this a new or the same terrorist ring, but in a different shape, right? Yep. Finally, coming to reinforced learning. Let's say I'm playing a cross of X and O's, right? Very popular game. I used to play a lot in my college when we didn't want to hear what the person ahead is talking about. Right? You may want to do it right now. So yeah, let's say I played some n number of games and I keep playing that game till I finally win, right? And thus, at one point of time, this is a very small complex set, right? Because if you can imagine, they're just like what, 9 cells, right? 9 operations that can happen at any point of time, right? And as per each move happens, the number of operations that can happen reduces. Very easy to reinforce and train this model on it, right? Say that, hey, keep simulating n number of games, or well, not don't even simulate, play n number of games with me. At one point of time, the computer would have figured out every possible move, every possible pattern that I'm going to play, and figure out how to beat me and figure out how to win against me, right? And that is what AlphaGo did, right? One thing that I just want you guys to observe is see the time under AlphaGo and see the time under Lee Sedol. Right? So Lee Sedol is the world #1 in Go, right? And AlphaGo was our program, right? Our computer that was, and the great thing was this system was learning on the live, right? It was taking inputs from what was happening and still trying to learn, right? And when it was trying to do this, if you see, Lee Sedol took nearly 28 minutes and 28 seconds to play all his moves before he lost this specific game. AlphaGo took just 5 minutes, right? So this is where it was trying to learn everything, build on the that Lee Sedol was playing, right? Simulate them, right? Figure out, hey, what are the best moves, right? And if you can imagine, you can't simulate all possible moves in such a situation within just 5 minutes of multiple steps. I think there are more than 120 steps that we're taking in this specific game, right? So you can't simulate at every moment 128 times before you play the games in 5 minutes, right? So that was where machine learning took ahead and said that, hey, this is what we're gonna do. This is what we learned from our previous games, and this is what we're not going to make the same mistakes, right? So let's come to a very, very simple example, right? Let's say you and I are opening up a tea store together, right? So tea is super popular in India. We do know that every tea stall is very famous, right? Do you guys have a favorite tea stall? Okay, do you guys have a favorite coffee shop? Right? Like, how many of you love Starbucks? A bunch of you probably love Starbucks. Then there'll be some folks who will be like, hey, I love CCD more, right? And then folks like me who will be like, hey, no, you know, like, ghar ki chai is the best, right? The tea that you can make at home is the best, right? The tea that my sorry for that. So yeah, let's say I'm trying to open a tea store and I'm measuring it by two ways, right? I'm trying to say there are already a bunch of tea stores in the area. There is the distance, like from a user, let's say I'm measuring from this specific room, there is a distance that each tea store has, and then there is user happiness, right? So if you can imagine, if you see the first tea store on the leftmost of this, you'll see that it is very close to this place and has a high user satisfaction, right? And then there is something which is slightly far off and has lowest user satisfaction, right? And similarly, there goes on, right? And assume this is the data that I have, and I am a consultation firm, or let's say we entered a partnership and we are opening up a startup, right? And we want to figure out where do we open the next tea store, right? So that we are at that optimal position. Because you can imagine, can I open a tea store just outside this hall? I probably can, but I'm going to probably have to pay a huge amount of money to just set up the thing and to IIT Delhi to use their premises, right? Can I open a tea stall just outside your gate, right? Yeah, amount of money that I would require is very low, right? So that makes it more easy, but you guys would not really come to that. You would rather go to this one unless I have something special, right? So you see, we have to figure out where do I open that one tea store so that I'm on that optimal line where I can be at enough distance so that you still visit me, but I give you good quality product and you have good happiness, right? So one way is, and this is the most simplest way, this is how all machine learning conceptuals or experiments should start, right? Uh, and I don't know, do you guys know about this theory called as Occam's razor? Anybody's heard about Occam's razor? Right. So it's a concept. It's just a concept I think that came in like the 1800s, if I'm not wrong, which basically says when things got super complicated, please remember that the simplest solution is the best solution possible, right? And I kind of use that in machine learning or problems also. I say, hey, take this, just draw a simple line into where people have been successful in opening their tea stores, right? So as you can see, I start from the most popular tea store and keep going down, and I'm able to figure out that, hey, this is the line. So if I'm anywhere near or around this line, I'm probably doing the right thing, right? So this is what I can do, but there's one problem in this set. I'm being too cautious, right? I'm being too rigid. My machine learning model at this point of time is too rigid, right? If let's say I was able to do something anywhere across this line, it would say that I'm doing the wrong thing. If I try and do something like this, right? This is a model that is too trusty. Trusty means I'm doing a thing, right, where what's going to happen is now I don't even know where to open my tea store. This is just too flexible, right? This says that everything that I will do is right. I can place a dot or I can open my tea store on anywhere, right, at any amount of distance, and it will still say you're doing the right thing. Okay? Why? Because it's too trusty, right? It's taking that everything being done here is it, right? What I want is something like this, right? It's flexible enough, but does not accumulate for the really bad experiences that are happening. So if you'll see, every store that is good happiness here is near or pretty much on the line, right? And the stores that have low experience are far from the line, right? And this is a machine learning model, believe me or not, right? How many of you know x plus y graphs, right? X plus y graph, we know y graphs, right? Two axes, x, y. Can you write this in an equation? Probably you can, right? The first one though we definitely can, right? It's just a straight line, should be a simple formulation, right? I write some variable of x, let's say ax plus by, right? Should be able to give me the answer, right? Here also, if I just take A and B as not as real, like I take them as real number but fractional numbers, I should still be able to build the same line using AX plus BY, right? Agreed or disagreed? You don't agree with me, right? No, do you agree or you don't agree? I would like if you don't agree with me. Right. Okay. The end goal, what I'm trying to explain here is that if you can draw a graph, right, and if you can plot this line into a mathematical formula, you have achieved machine learning. The model, if you remember, the brown box that I was talking about is nothing except that equation, right? I just need to place that equation into a system like Keras, like TensorFlow, like whatever the other systems are there out in the world, right? And once I place them in them, I've got a model working, right? And the A and B, if you remember from my equation, they're just weights, right? If you've kind of read on machine learning, you know they keep talking about this thing. Hey, you have weights with each feature, right? X and Y are my features, right? Which is distance and user happiness. So distance and user happiness are my features, right? A and B, which is the weight that I will attach to each one of this. Distance will have a certain weight and user happiness will have a certain weight, right? It keeps modulating as it flows through the graph, right? And with that, I'm able to come up with my machine learning system, right? And when I'm training my system, all I'm doing is I'm optimizing the weights, right? So if you'll go back to the first slide, I start with this, I give it an equation where I'm starting with certain weight A and certain weight B, right, for my X and Y variables. I optimize that, right? If I run too much training, I allow it to be too free, I'm building a model like this, which is inaccurate, right? Which will basically say yes to anything. And if I keep training them, right, but I don't train them too much, I have something which is like this, right? Problem solved. So we have built machine learning already, right? The workflow of machine learning kind of looks like this. So you start with the first step, which is training, right? You figure out what your data set is, right? You extract some features from it, you decide what features are there and not, right? If you start working with data sets, one of the core things that I'll recommend to you and will be helpful here during this hackathon and as well as all in your life is don't trust your data, right? Data is bad. Always filter your data, always clean your data. Data can be so much erroneous that it can cause huge problems, right? You can imagine if I allow a lot of bad data to come into my system, my machine learning model, right, or just any research model or any model that I'm using for any kind of computation is going to get spoiled, right? So always filter your data when you start, right? So extract that features, put that in a machine learning algorithm, give it some labels to start with, and thus you have a training built out, right? You can rerun this over tens and thousands and even hundreds of thousands of times, right? And thus you have great amount of training happening to your system. Once you have that, you'll have an ML model built out, right? Your algorithm plus the initial training data that you give it for each of the features that it is supposed to look for is your machine learning algorithm. Oh, sorry, machine learning model, right? Once you have that model, you start doing prediction on it. So you give it some input, it extracts the same features which it has. So in my scenario, X and Y, which was distance and user happiness, it maps it against, right, and tries to or give it a label, right? Yep. Uh, something that probably you can experiment with, but this is kind of like a generic framework that we work on. This framework is a 7-step framework which starts with define, right? Define the objectives. So I don't know what problem you have taken up for this hackathon, right? But whatever problem you have, you start with defining what the objective is. The problem is defined for you, but break that down, that problem into, hey, this is the objective that I want to extract from this machine learning system that I'm trying to build, right? Uh, Objectives could be like, hey, what is the insight that I want from my data, right? The insight that I want from my data is whether this certain thing is a apple or not. Right? Do I have labels on that data? Right? Can you create your own labels on that data? If you so a lot of times you will get pre-created labels, which is amazing, right? Guess how many times you get pre-created labels in real world examples? Zero. You have to mostly create your own labels, give it your own definition. Once you've done that, right, then you define whether you want to run a supervised or an unsupervised model, right? How do you want to train your models? right? If you want to do supervised learning, you can then have more control over the labels that are getting assigned, right? If you want to run unsupervised learning, then what you end up doing is that you have to build a system so that the labels can be automatically extracted or can be pulled it from a third party source, right, to build that. Yep, get data, right? Get as much data as you can, right? The more data, well, the more filtered, verified, sane data that your model can get help or can train on is the best you can do, right? So if you have less data, then it's actually like just stop. If you have, if you don't have enough data sets, and it's kind of like a vertical rule where you say, hey, if I want more features, I need more data. Right? And if I want more accuracy, I want more features. Right? I want my model to be nice or great, I need more features. If I need more features, I need more data. If I don't have enough data, please stop. Right? Do something else. Build a structured program, build something that you can work with. There is no need to keep going on with small data. You'll always be in a trouble where errors will keep happening. Right? Yeah, explore your data, right? So how many of you have data sets for your problems that you're going to do? How many of you have problems that you want to solve during the hackathon? Okay, well, that's great. Some people have problems that they want to solve, right? For the people who have problems that they want to solve, how many of you have data that you want to use? Right, super. Okay, at least someone has data, right? Not enough, but some data, right? Okay, you want to see whether it is over the tipping point of saying, hey, is this like, generally you want to go and collect more data. So let's assume you have a problem, right? And as you'll see in the next step, the next step, that you have a problem, right? You start with that. Once you have that problem, right? You have some data. If you move over, the first thing that you want to do is you want to explore that data, right? Please do not get started using your data without exploring it. Have a look at it, right? Uh, I know you're trying to build machine learning models, but please give it a human touch. Look at that data yourself, run it through your eyes, visualize it using all the variety of tools and graphs that are available out there, right? Then choose a technique, right? This is where you're choosing an algorithm, right? Do you want to do, so let's say you're trying to do clustering for your data, right? You have your objective in step 1 defined, right? Then you're going to start doing clustering on your data, right? Use one of the relevant algorithms, right? A lot of people ask me this question, what is the right algorithm to use, right? I don't have the answer to all of that, but what I know is that if you read in about the kind of problem that you're trying to solve, you will figure out the right algorithm, right? Generally, all real-world machine learning solutions that are available, they use an amalgamation of multiple algorithms, right? No one's daily inventing new algorithms out there. Most of the problems can be, to a certain degree, be solved with the decent accuracy with the existing algorithms or an amalgamation of existing algorithms, right? So that is what you want to do. Yep. Tools and techniques. Now is the thing that, hey, how do you start implementing it? Till now you're just like theorizing how you want to solve the problem, thinking about what to do, right? Now you can start thinking about, hey, what tools that I want to use, right? There are multiple tools available, right? So there are generic machine learning platforms like machine learning, Keras, Abe, and many other that are available which you can use, right? So these have generic models. You can put your own model in it, or these have a lot of pre-built models available which you can just plug in and start using ASAP, right? Then you want to do some kind of data analysis, understand your data. You have things like rank lab and p recognition available that allow you to do that. It's actually pretty good. I've been using it for a long amount of time now myself, right? So yeah, what you want to do, there are multiple tools available, right? Yep. Finally, building and training your model, right? So you know what you do, you've defined, you figured out the tools that you want to use, the techniques that you want to use. You start preparing your data, train your model, right? Run through a few iterations of training them, try them to, hey, validate, right? Generally, what you'll do is whatever amount of data that you have, and this is what you'll also see in the lab that we're going to show you, is that you, let's say you have 100% data, right? You will take 90 or 85% for training, and you'll leave the 15% or the 10%. You're using that to validate, right? That is your validation data, right? Now you're using that because you can't let a model go and like try out there in the world without testing it, right? And the test data is something you haven't trained upon. Please note, test data always should be that you haven't given it as training, right? So that is why we're going to segregate like 10-15% of our data sets so that we can validate it or test it against in the end, right? Yep. Finally, deploy those models. The first steps that you saw can either be done on paper or on local laptops. You rarely need like super large amount of compute for that. But finally, when you need to deploy them, you need to push them onto a system like maybe cloud or maybe buy your own like mini cluster somewhere around here and start deploying that. Once you've done that, like all software systems, please monitor them, please maintain them. Don't let them go around and like give like super wrong results and keep telling that Rohit is a nerd and Ranjan is a super cool guy, right? Cool. Yep. So this is how you build your own models. If you don't want to build your own models, what is the solution out there? Something that I think our IBM friends also talked about, which is there are pre-made APIs available, right? Google also has a bunch of pre-made APIs. As part of our Google Cloud offerings, we have something called as Vision API for taking images and input and recognizing what those images have, figuring out whether those images are safe to use in your public project or not, and things like those. We have Speech API, which can take speech including Indian accents and give you the text out of it. We have natural language understanding, which can take the text that you've extracted or just give it some text and it can give you natural language concept. We have translation API, which is an API which is pretty much of you know at translate.google.com, right? We also recently launched something called as video intelligence, right? Give us a video and we'll process that video in real time and give you labels based on that, that hey, where are people in that, what is happening in the various scenes, right? What is the overall understanding from those videos. Let's say you are saying that hey Rohit, what you're talking about is it's too noob, right? It's too like too easy. We want to do the hard stuff, right? And we really encourage you to do the hard stuff, build your own models. If you want to do that, you can actually build them on Google Cloud also, which you'll see in the lab as we talk about that later. But basically, we've got tools like BigQuery and Cloud Machine Learning and Data Lab to help you easily navigate through your machine learning journey. Finally, yes, you can build your TensorFlow models and run it on your own hardware, probably run it on your laptops or probably run it on your own data centers. Yeah, the great thing is as these go on, so the top level is the most easy, but the bottom level is something you can most customize with. It gets hard for bottom in this graph. Yep. So yeah, this was my part. Now coming to the more concrete stuff that is going to help you through the next 2 days, which is talking about core TensorFlow. How do you use the core TensorFlow APIs, and what models or what programming framework is TensorFlow giving you to work, right? So for that, Manoranjan is going to take the lead.
My name is Manoranjan Padhy. I work with the Google Developer Relations team in Bangalore, to be specific, ecosystem team. Uh, we are an eng team basically who helps external developers. Uh, if you are using our platform or if you are trying to get started with our platform, on how do you do that? So ours is also the team that the code labs that you see basically on developers.google.com or the code snippets that you see is written by some of our colleagues based out of Mountain View in California. So I belong to that team basically. So let's get started with TensorFlow. How many of you have done TensorFlow already? How many of you have written on your own models in TensorFlow? How many of you have written your models ground up and not based on anything? Sorry? I can't hear you. Okay, you used optimizer. Fine, thank you. Uh, TensorFlow is an open source machine learning library, as Rohit mentioned. We have been building it or using it since long back, but then at one point we thought that why should we open source it? That was the reason sometime in 2012 or 13, we decided to open source TensorFlow. TensorFlow is still in its early releases. I think just last night we did a minor update to TensorFlow 1.x version. You can check it out. The release candidate should be 1 as of now. It's 1.3 or 1.2. I'm not very sure. I saw that email when I was half asleep, so I don't really remember, but you can definitely check it out. So what I mean to say, TensorFlow is very uh, early in stage. We are still trying to solve a lot of problems, like for when we were in 0.7 or 6 was the time we announced GPU support for TensorFlow. It wasn't there earlier. So what I can say is a lot of features are coming up. So if you don't find anything that you want, give us feedbacks. That is how we build things up. And definitely keep on trying things. It is fine if you fail. We believe in this philosophy is if you want to fail, fail fast. Get started quickly again. So what is TensorFlow? It's a funny sounding word, but tensors, what it literally means is a multi-dimensional array. How many of you know what an array is? How many of you can tell what is an array is if I ask you today? Yeah, that is the problem. Uh, most of us know what things are, but we are not able to explicitly mention it. We can visualize it, what thing it is, but we do not, or we feel that we be correct. With graph of operations, so TensorFlow in brief is it's a multi-dimensional array of graph of operations. That is the reason it's called TensorFlow. It was built by the Google Brain, which is headed by Jeff Team. How many of you have heard about Jeff Team? Okay. Uh, Jeff Team
I
one
kind
of
of
the
just mentioned him in my first talk, Jeff Dean. So you should have heard about him.
Jeff Dean is one of the early employees at Google. Jeff Dean, Andrew Ng from Coursera, who just announced DeepMind.ai, if you are following up. And then there was one more professor from Harvard. They recently started the Brain team, and later Jeff Dean took it forward. Jeff Dean is one of the smartest persons inside Google. We call him so smart that we have several internal jokes about him. It's like the PIN number of his credit card is the last 4 digits of pi. So yeah, he built Tensor, all the machine learning things or what all machine learning techniques that you see in any of the Google products was spearheaded by him, or he started him, or he's the guy who wrote the soul of that thing. So do search for him. So all you can run TensorFlow. One is your laptop. Depending on which GPU you have, you can install a CPU version of TensorFlow, or you can install a GPU version of TensorFlow. Really, I would request you to install it from source. But if you're not able to install it from source, you can simply use a Docker or any comfortable or any easy method that you think is suitable for you. Second, we run it in data centers. Like for this time, we announced an upgrade to the TPUs, the tensor processing units, and cloud TPUs basically. We also have TPUs available for education sectors. Then again, you can get clusters if I'm not wrong. Yeah, but you need like someone from the administration of your college need to request for it. We usually review those requests and then allocate you a cluster of a TPU, which you can use for educational purposes. And I don't think we charge for it. But then you can run on your mobiles. When I'm saying mobile phones, it is not training your model on mobiles. It's just you are getting the label of that particular thing. Third is Raspberry Pi, or yeah, Raspberry Pi is the one that is most currently supported. Recent example of it, a farmer in Japan used Raspberry Pi and was running TensorFlow on top of it, and he built a classifier which was predicting, which he built a sorter actually to sort the correct cucumber from his farm and then send it to the market. Results, he was able to earn more profit by selling that particular vegetable. So do check it out. I think it's there on YouTube as well, and it's insanely satisfying to see that video as such. Second, how does it work? There are two things that I would like to show you. One is the Python program if I want to write particular getting started guide, and second is how the graph looks like. It's the DFG. I wouldn't go in detail, but we will take it up when we are doing that code lab thing. And second thing, you can also see all these things on tensorflow.org and getting started guide. So one thing, you should be good with Python. I hope you're fine with Python, all of you. Who is not fine with it? Okay, we have other language support.
More specifically, how many of you can read Python? Like just generic read, no special stuff, just generic read, right? Yeah, you're good enough to like go ahead. It's not complex Python. All you're doing is just using Python and calling various functions or methods.
So what I'm doing here is I just want to know the loss, and then I'm writing an optimizer, then the training data part, then I'm doing loops of training. I can change how many loops or how many iterations I want to do to, and at the end I can get the output of my data. So what I think would be a correct data set is 1,000 or 1,500 samples for me. If anything less than that wouldn't give you a lot of accuracy. So yeah. The languages that are supported as of now is Python. Why I asked Python is Python was the one with which it was introduced to, and it is 100% supported and compatible. We are still trying to come up with C++, Java. It is there at some point, Go, but then again, it's not there 100%. So if you are even able to read Python, you should be fine with it. So what you can do is TensorFlow provides great tools like TensorBoard, where you can see the visualization of your data. How many of you have heard about TensorBoard? Right. So to see a live example of TensorBoard, you basically run on your local. You can run on your local machines by going to a local host, defining the port and all those things. There is a code lab called TensorFlow for Poets, where we are taking a sample of flowers, and in that sample of flowers, we are just visualizing it with the help of TensorBoard. Definitely check it out. Now, second ways to use TensorFlow, one is the neural machine translation. It has reduced error when we are doing it internally by 55 to 85%. So we are using TensorFlow in a lot of our own products as well when I'm talking about it to you. How many of you have tried to change their images? Like I remember 6 to 7 months back, it was also being shared a lot on Facebook. Or maybe I have those friends who do a lot of these things. At least they were sharing it. Just give image and it would superimpose your image with very different outputs. Second is neural architecture search. This is an example of the way Google search works. So out of a lot of products that we have, search is the most complex things that we have ever built. And we are still not very good at it, I can say that. It's just an example. There are links. If you can go to arxiv.org, there are a lot of such case studies which you can refer to. Okay. Then how a blue and yellow train traveling down train tracks, a person on a beach flying a kite. That's how I can differentiate between images as well. The number of Google directories containing model description file. Again, TensorFlow. If you get some time, go to github.com and see Google's account. There are a lot of such folders related to every product, which contains some of the example that we can share on how we are using TensorFlow, that particular thing. In February or March, TensorFlow was having the maximum number of stars and one of the most popular repository on GitHub. Others are Scikit-learn, Cafe, CNTK, MXNet, Torch, and Theano. TensorFlow was 44 when just last year. Then again, one thing you need to realize is you do not need machine learning for everything, if someone says you. There would be some examples which you can simply build without machine learning. Second, it is not also necessary that you need TensorFlow to solve certain problems. Maybe you can simply use, if you're getting started with it, scikit-learn and build your models. TensorFlow is very, very much used when we are talking about deep learning. So can anybody differentiate between machine learning, simple machine learning and deep learning? Yeah? Okay. Sorry? Yeah, please close. So when there are more than one hidden layer of neurons, I can call it deep learning. So when I am talking about more than one hidden layer of neuron is the output of the first layer is not visible to the third layer. Let's I can say that. Or the output of the first layer is not visible to me as a programmer who have written that model. But when it contains as a single layer, I can call it machine learning. But when it's more than one hidden layer, it's deep learning. Second thing you can also try it out if you go to tensorflow.org. It's called a TensorFlow playground. If you can just do Google search, it is a model that we have already returned. You can select type of data sets you want to enter into, and we guarantee you that it won't break, no matter how much iterations you run. Yeah, here you can see that is the data set, which data set you want to use. We are giving you 4 current uh, samples of it, and then how many number of hidden layers of neurons do you want to attach. Right now we have 2 hidden layers, but I can then remove it, just keep it 1 layer, a 0 hidden layer, then it's simple machine learning. Not a lot of maths, not a lot of thinking going into, but plain machine learning. But as soon as I start, Rohit, can we run the model?
Yeah, so like what you see here that instantly my model is too simple, my problem set is too simple. Instantly my training loss reduces, which means my model is as good as it can get, right? Uh, if I were to probably make my model slightly more difficult, or well, as and I have 0 hidden layers here, I start training it. As you can see, it takes a lot of time to get it done.
Around 230 iterations.
If I add a bunch of layers and I run it, as you can see, my test loss just came to 0.00 or 0.001 as fast as. So the last 2 examples you saw, we were just unable to reach the training loss of 0. Right here, my model is saying this is, I've literally learned everything from your data set that is possible, and I'm solving all problems possible.
You can try it out on your own. It's playground.tensorflow.org. On your phone or on your laptop, no matter what, you can visit. It is running on our servers. You just need a stable internet connection to try it out. TensorFlow version 1. This is the stable version that we have come out with. We just started with support for CPUs running on Linux based system. Then we provided support for GPUs. Then we came out for support with Windows as well. But Windows, it's not still very, very advisable to use on that, but it runs flawlessly on Linux systems. And if you have a GPU, it will be more better. Second, yeah, it's fast, it's more optimized. Then the XLA compiler is more better than what it was before the 1 version. Right now, what we are coming out with is just minor releases. It's based on the feedback that we get. Then what it's happening is P100 is the model of GPU and K80 is another model of GPU. What you can see is for P100 it's 7.3 speed of 8 and then 7.5 speed of 8 GPUs. Recently we came up with our own custom built GPUs and we tried to compare it with other GPU providers and we found out that what we built was much more faster than the existing GPUs because That particular GPU was built keeping TensorFlow in mind in the first place. And that is the same thing what you get is in TPUs, that is tensor processing units. Then it's an experimental TensorFlow compiler. Maybe we'll see more on it when we are looking at the code lab part of it. We can start with the code lab. The time we have in mind, we'll just skip to the code lab after this. I think just have half an hour. Yeah, so how the framework is built is TensorFlow execution engine is there in the bottom. And below that, there's GPU, there's Android, iOS, CPU, or wherever you are running it, basically. And then there are various layers which build the models again. And after that, there's estimator, Keras models. Keras was something that we recently added 2-3 months back. And then there's caned estimators, that's models in a box. This is a brief overview. Until and unless you are not going to do a lot of research in it, you can just simply keep in mind that something like this exists.